Hi, this is Mr. Ford, and today's video is going to be on plotting points. Something seems so easy, but actually works into so many different capabilities, works into things like Lorenz curves, actually applies to bar graphs as well as normal line graphs. Of course, is crucial for understanding data. So first thing is you can see here that we got our setup here. So we got scale for both axis setup is extremely important. When you're setting it up, you need to make sure that you've got it as large as possible in the space you've been provided. This allows for a greater accuracy. If you have a really small graph, you can't really do much analysis from it. The next thing is you need it as an even scale. So you need the equal gaps as you're going up, and you're going to see that when I do this first question. And once you've done that, you need to make sure you label it. So you label your axis. So you need to label what is going on the axis, but also what are the units if there are units present, because there usually are. Okay. The last and very important thing, which I'm always telling my students, all points have to be extremely accurate. If they're small squares, you only get one small square deviation, so away from where it should be. If it's a large square, you're not even allowed that. It has to be probably half of that square, or you will lose marks. Now, that seems very minor, but of course, being able to do things accurately is very important. So we have some more information here. So when we're drawing, especially in A level, in GCSE, they give you the access to draw on, and you just go ahead and plot. Now, obviously, you're progressing more, and a lot of you, especially those in geography, will be doing coursework where you need to plot your own graphs. So you do have to be able to draw your own graphs, so that you will be examined on that as well. So you have to draw your own scales and graphs for yourself. Okay, so everything we just talked about is very important. Now, because you're drawing your own graphs, this is why they need to be large. So if I was to draw two lines, if I was to draw a graph that is this big, if I was to draw a graph, just a little sketch of a graph that is this big, and that is this big. If I have one that just looks like this, and then I have one that I actually looked at it and it goes like this here, I can already see these might be the same pieces of data. But you can see a lot more information on the right-hand side. You can see that it actually goes up with quite a high rate of change, and then the rate of change changes, so it gets less steep towards the top. The smaller your graph is, the less information you can take out of it. Now, the next thing we'll be talking about, we won't go anywhere. So we're going to talk about line graphs and bar charts in this video today. But the line of best fit. The line of best fit can be straight ruled, or it can be a curve. It matters on the data you've been presented with. If you're told it's going to be a straight line of best fit, use a ruler. But generally, a line of best fit. Now, the best is where we got the information. We're talking about a best fit. It's supposed to fit the data. So, all we have to do is think about it. If it looks like a curve, it needs to be a curve. If it doesn't look like a curve, and it looks like a straight line, it's a straight line. There's another video that we'll be doing on scatter graphs and scatter diagrams. Now that is where you use a straight line. That is where we've got other things going on because of the type of data it is, but that's something we'll come to later. So first off, I've got an I do section here, and this is the data we've been given. So a student is looking at growth and effect of bacteria on fresh milk over several days. So they've done this experiment. It starts at a pH of 7, and over 6 days, it reduces from 7 down to 4.5. Our first task is we want to sit there and actually draw this. So let's have a look at what they've given us. So if you have a look here, now I've written those values on next to me, so I have them for me. But we need to complete the graph. This is exactly what you've been given. You will notice, I'll zoom out slightly. You'll notice that even though we are given pH, so it does give you some idea in this case, not always to start, but you aren't given the x value. So you know that across the x axis, we're going to have time. Generally, you want time on the x axis. The only time that you don't have that time on the x-axis is when you do time dilation, which if you're doing that, you're looking at your high-end physics, and and I'm really hoping that you're beyond this video. So we'll have time generally on the x-axis. Continuous data is generally what you want on the x-axis, but the x-axis is, as it says above, the independent variable, the thing that is changing. Since in this case, it's the time. We are measuring the effect of pH over time. So time is on the x-axis. So what we want to do is we have 6 days. Now, there's a couple of different ways you can do it. You can do it mathematically. You can add up all the boxes and divide it. But I'm telling you right now, you don't need to. You can even just guess and check. It's a great method. So let's have a look. We want to use the most amount of space here. Now, this is a mistake that happens. If I was to go, all right, so look, this looks like a lovely spot to put 1, 2, 3, 4, and 5. 6, because we've got to get 6. If you notice now, we've only used half of the space provided. So that means that I'm not only wasting all of this space, waste of paper, but more importantly, that means I'm going to get less information out of my graph because I've squished it. So what I actually want to do is I want to use a higher scale. Okay, so let's try something else. Now, this is when it's guess and checks. I can try every 3. It's weird, but I can try it 1, 2. That's 1, 2, 3, 4. It doesn't fit. So it doesn't take any long really to do this. I don't have to draw the marks. You could just sit there and count them out. And if it doesn't fit, try a different scale. Let's try on the last one. So every 2. So this is day 1, day 2, day 3, day 4, day 5, day 6. So this would be day 0. 1, 2, 3, 4, 5, 6. This fits. It fits the majority of the paper, fits most of the graph. Okay, it's not too small, and it all fits as well. This is going to be time in days. Okay, where this represents the days. You'll notice pH doesn't have a unit because pH is both the unit and the label. But if I wrote time, is this in minutes? Is this in hours? You have to write days because you need to know what units this is in. Okay, plotting. So this is like you've done before. Now, previously it says on 0 days, it is 7 pH. So on 0, and I go up, I can use a ruler, 7. Now, I always put a cross. The reason is if students start putting a circle like this, it gets less effective. The reason is if I put a cross, I know at the intersection in the middle, that's the value, where here is the value in the middle of it, to the side, above, below. It creates more possibilities for error. So always use a cross to draw your points. At 1, it's still 7 days. Okay, you can even see the accuracy is slightly off, but it's still within my tolerances. 2, I've got 6.7. At 3, I've got 6. At 4, I've got 5. At 6, I've got 4.5. At 5, I've got 4.5. And 6, I've got 4.5. Okay. Now, as you can see, I now have a plot. Think about it. Does it look like a straight line? The biggest point is, I would say no. It does not look like a straight line. It actually looks like it curves down. So that's what my line of best fit should look like. So I'm going to try here, but I'm going to pause the video because it's going to take me, and I'm going to draw. I'm going to draw 2. I'm going to draw you a poor example and a good example. Now, this is my first. Now, it's very adamant, as you can see here. This is my first attempt. You'll notice that it goes through every single cross. That's good. What is bad about it? This is known as feathering. So when you're doing art, you sometimes sketch like this. Now in school, I used to do this as well, and it was something that I was just told you can't do. And it's true, you can't do it because you don't know where the line is. Okay, so here, this is not correct. It has to be a smooth, continuous line going through all the points. Okay, so it has to be smooth. You can't feather. You will not get the mark for it. Smooth, continuous line. Okay, now this one's much better, and that get me the marks. Now, that doesn't mean I never lifted my pencil from this pad, but as I'm going through it, you'll notice just here, I've actually had to lift it just slightly, but I've continued the line. So it's not feathered, it's a continuous line all the way through. And that would give me my marks for this. My 4 marks for graphing. Okay, one mark for plotting, 1 mark for my label. Sorry, 2 marks for plotting, 1 mark for my label, and 1 mark for this line of best fit that is smooth and continuous. What I want you to do now is I want you to try this question here. Now, this is a frequency polygon, but there's information here for you, but give this one a go. You will have to do both the X and the Y scale. Give it a go.